Welcome back, guys. In the last video we went over the data types, which are the arrays and the tuples and etc. We also went over the loops. In this video I want to go into great detail about some data types and the functions you can use on them. So yes, we will start with the strings. So for the strings, we're gonna run this file that we have over here, and we're gonna walk through every output. So we will start off with the first print function, not even the first example. The first print function prints this string, and as you can see, I used the asterisk or the star or whatever you want to call it for multiplication. So I had this print function print this dash 20 times, and this is how the output looks. And then plus space strings space and then another dash 20 times, and this is how it looks. So let's dive in with the first example. The hello world string we have here, we're gonna be doing this dot upper function on it, and then we're gonna print it. You can see here I'm calling my string variable again and then reassigning it the value of whatever this upper function does, because if I remove this wouldn't work. So the upper, we have the string here, the upper makes every letter uppercase. If I remove this and I'm not calling the variable and assigning it the new value, so this is what happens. Yeah, nothing happens, which is why we are assigning it the value again. Now don't worry about this syntax error, I'll get to it in a bit. The second example is the opposite. We have a full string of uppercase letters, and we have this dot lower function, and the output is everything in lowercase. In the third example, we have the usual string hello world, and this time we have a count variable. This is a different variable from the myString because we are using the .find method, and we are looking for this double LO string inside of our string. So what this will do is return the value of 2, which is basically the index of where this substring was found. So H would be index 0. If you remember the last video, we talked about indices in arrays. It's the same for strings, so H would be 0, E would be of index 1, and the first character of the substring we're trying to search for, this will be the index that gets returned in the count variable. Now in the fourth example, the same string, this is a bit of a confusing method. It's called the .join, but you can see the output here. So we are choosing a string, we're putting it on the left, then we type in .join and then the second string that we want to make this operation on, which is our string, and this is the output. As you can see, the .join joins every character of the string we have and places whatever string we have here in between every character, including the spaces, because yes, the space is considered a character. And another example of how this join could actually be useful instead of this confusing way would be using it in a list. Here we have an empty string. As you can see, this is empty. If I put a space it's not empty anymore. It's considered a space, which is considered a character. So this is an empty string, and if I do the dot join on the list, I know this is a function for the list, not the strings, but this is very useful to know. I will show it again when we get to the lists. But yeah, as you can see, it joined every letter inside of the list. In example 5, we are using the count function. This is the count variable. This is the count function because it has a parentheses at the end, and we are passing something into it which would be called a parameter. You will know about them when we start explaining the functions soon enough. What we're doing here is we are counting how many times the L character was seen in this string, how many occurrences, and we have 3 occurrences. You can also add indices. For example, I wanted to start from index 3 and end at index 10, which would be here 0, 1, 2, and 3. This L would be the starting point. 4, 5, 6, 7, 8, 9, 10, and D would be the endpoint. So we are searching for how many occurrences L has from index 3 to 10, which would be in this substring, and it's 2. This start you are seeing here, this is the PyCharm IDE writing it. This is not actual code, so don't worry about that. Just worry about the L, comma, 3, comma, and 10. Now in example 6, we go over the split method, where we have a string, and if we don't pass any parameter, by default it will split our string using these spaces. So as you can see here, it returns a list of every string we have that is separated by spaces. And this is what happens when we pass a parameter. For example, an L substring. Every time the L substring is encountered, it will get split and put in a list. As you can see here, we have HE, then an L, so it's separated. Then between these two L's, it's empty, so you have an empty string here. These quotation marks, they delimit the string, so this would be the start of the string, this would be the end. As you can see, it's empty. And then we have the O space WOR because there are no L's. When you encounter the L, again you split it and you have the final string. Now in example 7, we are using the dot strip method. This is useful for general formatting. You can see it's stripping the white space that you have here, and it's keeping only the word. This could be useful for login forms if you are taking the username and password and there are redundant spaces at the end or at the start, and you want to remove them. This is your go-to. In example 8, we have the .swap case function, which sounds straightforward because that's what it actually does. It swaps the uppercase and lowercase letters, as you can see here. Now, this is an important part called string formatting, which is how we can manipulate the output of the string. So, in the first example, we have this single quotation and double quotation. Both can be used to let the Python interpreter know that we have a string here, right? We can use the double quotations or the single ones, but what if we want to use them inside? So here you can see if we use the double quotations, we are free to use the single quotation inside the string, and the opposite is true. If we use the single quotations, we can use the double quotations. If you want to use the same type, you have to do this. We use the double quotations, and in case we need double quotations inside of our string, you need to call a break, which would be the backslash character. This lets the Python interpreter know that we want to do some formatting inside the string, and the Python interpreter looks to the right of the backslash and it sees a double quotation, so it knows this doesn't limit the string, it's inside of the string. So if I remove this, you can see this changed colors. Now now the Python interpreter thinks this is a variable because it's white, it's not green, which means it's a string, and this is wrong. So there we go, backslash. And as you can see here, they get printed out correctly. Now in the second example, we go over the backslash and what we can use after it. So you've seen the backslash n many times already, and here what it does is it prints a new line. So it goes straight to a new line. The space before the what is this space over here. This is like pressing enter right after finishing a line. This is what the n does, it's a new line. The backslash t in example 3 basically adds a tab character. As you can see here, this entire white space is the tab character, which is equivalent to 4 spaces. It's not 4 spaces, it's equivalent to them. In the fourth example, what if we wanna write a backslash? This is the way to do it. You can just write a second backslash and it gets written. However, you can write it in the string immediately, but this results in this syntax error that I told you about, the invalid escape sequence backslash, because the Python interpreter looks at this backslash and tells you that there's nothing after it, so there's something wrong over here. Which is why, if you want to avoid this syntax error, you can use a double backslash to let the Python interpreter know there's only one backslash here, don't take this as an escape sequence. Now in example 5, this is how you can, this is a easier way of adding variables inside of the strings. So we have the name variable here, which is Richard, and we have my string. So here you can see the quotation marks don't include this F character, yet this F character is green, which is how you let the Python interpreter know that this F means there is formatting to be done inside the string. And you can see these squiggly brackets, they are orange. If I remove this F, this gets interpreted as a normal string. If I add the F, the Python interpreter knows to look for these brackets because we can add a variable inside of them, which is the name variable in this case, and we have hello Richard printed out. And in the final example, for strings, we can use these 3 quotation marks, as you can read here. This is useful for printing large paragraphs. You can also use this to quickly comment out large code. You can see I can use the double quotations inside because we are using triple on the outside. Large code instead of using the hashtag character. So what this means is, you can see here at the start I have this string comment. Let's say I wanna comment out example 1, 2 and 3. Instead of going like this, adding a hashtag before every comment or every line, my bad, I can just add 3 quotation marks here and 3 quotation marks here, and this works with singular quotation marks. Now the Python interpreter thinks all of this is just one big string and it doesn't run this code. This is a faster way to just leave out big code that you don't want to run in this moment, but you don't want to erase as well. And you can see here that every new line, well, when I press enter, it creates a new line character. I don't have to write the \n. When using the 3 quotation marks, you can see for yourself, it goes to the next line by itself. Now for the lists. In the first example, we have this dot append function, and let's run the file. The dot append function is used to add elements to the list. So you can see here the 3 is added at the end. The insert function in the second example is used in case you don't want to add to the end of the list, you want to add in a specific location of the list. So you can see here I'm specifying an index 4 and I want to add 3 as a value. And you can see here this is index 0, index 1, 2, 3, and the fourth index is my object 3. All of these get pushed to the right, or the index becomes +1. So here the 5 is index 4, here it's index 5. Again, this is printed by the IDE. You don't write index, you just write the value. Now in the third example, we have this remove function. Here you specify the object that you want to remove. So if I want to remove 3, I have to write 3 and it gets removed. Now pay attention, in the example 4, here I'm specifying the index of what I want to remove. So the remove needs a value, the pop needs an index. You can see when you press dot, the remove needs a value, right? But the pop needs an index. The PyCharm IDE tells you what you usually need for all of these. So the pop needs an index, the remove needs a value. Right, now in the fourth example, the special thing about the pop function is that you can see I created a variable x and I'm assigning this value to it. You can see that I'm printing it and you can see the value that I removed at the fourth index. This is what the pop function does. It remembers whatever you removed from the list, as long as you can store it at a variable at the same time as you remove it, which would be creating the variable and immediately assigning the value using the .pop. And there we go. In the fifth example, we use the .index. We are looking for a value of 4. We want to see the value for what index it has, and the result is 6. So the index of 4 is 6. You can see 1, 0, 1, 2, 3, 4, 5, 6. 6 is the index. In the example 6, we go over the count function, which counts the occurrence of the number 3. And we have 4 occurrences, and it prints out 4. In the seventh example, we have the .clear function, and this is a straightforward one. It clears the list. It doesn't delete the list, it just empties it. This is an empty list, as you can see. It's not deleted, it's just empty. You can use the .append function to add to it again. It's not deleted, it's still there, just empty. In the eighth example, we go over the copy function. This is very straightforward again. This is mylist2. This is another variable, and we are printing the mylist2, not the mylist, but we are copying the mylist variable, and Yeah, that's it. In the ninth example, uh, before I go over the ninth example, this can be substituted. Uh, Look at this. My list 3 can be equal to my list, and if I print my list 3, the eighth example is the same. This is the same as using the .copy function. This is just in case you might need the copy function at any time you might be coding. It's there, but you can just do what I did and set it equal directly to the variable that you want to copy. Now, in the ninth example, we have the sort function, which is straightforward. It sorts your list. In the 10th example, we also use the sort, but we type in reverse equal true, and the list gets sorted and then reversed. You can see the syntax here. When we go over functions and parameters, you will understand the syntax more, but the only thing you need to worry about is just how it looks and memorizing it. It's just reverse equal true. Right? To make things clearer, you can do the same here. Index equal and value, was it? Value equal, and this would work the same. This is the same idea. It needs an index and a value. You can specify that this is the index and this is the value. If you do specify, you can switch them, the positions, because then it's clear to the Python interpreter which is which. So that's for the 10th example. Now pay attention, in the 11th example you are using the reverse. This reverses the order, but in the 10th example we are sorting and then reversing. So in example 11, the reverse function only reverses the order. Now let's take a look at non-integer only lists. You remember in Python we can have more than one data type inside of the list. Most of these functions can be used in any type of list, but anything that has to do with the actual value of numbers, for example the sorting, you're better off using it for numbers only. So here we are going into the non-integer only lists. For example, this is a list that has strings only, and this is how we join them. We are going over the join function. We've seen this in the list, the strings section, my bad. And we are joining every element in this list with a space, and there we go. We have a string that gets printed. In the second example, this might get a bit confusing, but these brackets are used to access the value inside of the list. You should already know this from the first time I showed you lists, and it should be in the loops, which would be the last video I did. If I want this string there, or in this case the index 2, 0, 1, 2, I want the friend string, I have to use the brackets and then put 2 inside of it, which is the index of the string. Now if I add a second one, I'm accessing what's inside of the string. So the first one, I'm accessing the second index inside the list, and the second bracket is accessing the second index, the values inside of it. So this would be the third index 0, 1, 2, 3, which would be the E character, and there we go. If you find this a bit confusing, the third example should clear it out a bit. We have 3 lists inside of this list, and this is considered a matrix in Python. This is how you would normally write a matrix. This is a 3 by 3 matrix, and the first set of brackets accesses the index number 2 inside of the list, which would be the third list because 0, 1, and 2. This is how the indices work. And the second pair of brackets should access the index 1 inside of this list, which would be 2, and if I print it, we get 2. This should make it more understandable because we are using a list again. It might have been confusing inside of the strings, but this should be more straightforward. Another example is the example number 4. Here you have to pay attention that when you search for the index 6, you are searching for it inside the entire list. So in this example, the Python interpreter would go inside of it and look around and say, I found 3 lists, but I didn't found 6. I only found 3 objects. Each one is a list. I didn't find a object whose value is 6, so this would be an error. What you can see here, I added the brackets with the index 0. So instead of looking through the entire list, it looks only inside the index 0, which is another list of its own, and it looks for the index of the number 6 inside of it, which would be 1 in this case. And that's it for lists. For tuples, I will not go over them because tuples are lists that cannot be altered after creation. So the append would add something to it which would alter it, so the append does not work. The insert, the remove, the pop. The index works because you are allowed to look for the index of something inside of the tuple. Same thing goes for count. Clear does not work on the tuple. And yeah, most of these don't work other than the index and the count. The copy obviously works because you are only copying it, you're not altering anything to it. Now for the dictionaries, let's run the file. And in the first example, we have this my dictionary with Karim and the value 19. These are keys and value pairs. The first function is get, and for the get we need to give it a key, and if we store it in x and print x, we get 19, which is the value that Karim has. In the second example, if we use the .pop and we give it a key, Maya for example, and then we print the my dictionary, it prints the my dictionary, and you can see Maya was removed. But if we store the pop in x, we get the value by itself. In the third example, if we use the .items, we get this dictionary items, and as you can see, it's a list, and inside of it are tuples for the key value pairs. Now how you access this, you would see in a second. Because it's not a normal list that you can access, the type is dictionary items. The type isn't a list. You will see how to access this. And in the fourth example, the update, you pass to it a dictionary. It could have one value or many values. In this case, it has 2 values, Anthony and Sarah. And if we print the dictionary, you can see they were added. Keep in mind the dictionary doesn't work on indices, which is why you use the .get with a key. There's no index. Now in the fifth example, you have the .keys function. The .keys returns the dictionary keys as a list, and this is how you can access them. You make a for loop for I. I is our variable that will go through the entire variable, which is x. It will go through each value that is inside of it. So for I in x, and if we print my dictionary dot get I, you get every value for each key because we are using the dot get function. If we print I by itself and we run again, you can see we have the keys. This could be useful for searching a specific key. So if you add a if statement, and let's say if this string is equal to I, let's just go if Karim is equal to I, double points, print I. You can see here when it finds Karim, it prints it. So instead of the print, you can do whatever you want. This can be useful as a search function, but we will keep it like this for now. Let's run again. There we go. In the sixth example, we have the dot values, which is the same as in example 5, but instead it gives the values instead of the keys. And in example number 7, we have the .pop item, which removes the last item. And if you use x and store it in a variable, you get the key value pair as a tuple.